Hey there, welcome to my channel KB19 Fundamentals by Abir Chakravorty. This is the next installment of video in machine vision and grippers in the food industry. Here we see how the machine vision and grippers do affect the food industry. So here we see an assembly line, so machine sensors, and there is a labeling which is being done with the help of an automated gripping system, a machine vision system. So this is a machine vision system. Now, if we move on to machine vision, first we talk about our human vision. So these are our eyes. When we perceive an object in biology, basically it is known as a binocular vision. It's a type of vision in which an animal has two eyes capable of facing the same direction to perceive a single three-dimensional image of its surroundings. So binocular vision does not typically refer to a vision where an animal has eyes on opposite sides of its head and shares no field view between them, like in some animals. So where there is a binocular vision, the two eyes here, these eyes share the same vision or the same image. So these two eyes basically perceive a 3D image. And so while they perceive, this is with the help of these two eyes we calculate the distance between the three-dimensional objects or the two objects, and this is known as, with the help of a stereo vision, we are calculating depth calculation. So while we progress, so this is basically the binocular vision in which we perceive a three-dimensional image. Now if we move like analog image and or a stereo image further, and so human vision is a binocular image. Now if you talk about analog image, electrical signal, for example, the output of a video camera that gives the electrical voltage at locations in an image. The analog means it is continuous function of time. So the analog signal can be converted to digital signal by the process of sampling and quantization. So when a light source is falling on the imaging system, sample and quantize digital storage, digital computer is there, online buffer, and display image and output quality is there. So a typical digital image processing sequence, a pixel value depends upon processing sequence is composed of an object, and then a light source, imaging system. We have sample and quantize, digitize section. We are having storage sections. We are having digital computer process section, online buffer, refresh store, display, record, and output. So these are the basically how it is being done. Now if we see another object, if we see the surface properties, suppose sunlight falls on a certain object, sunlight is falling and it is being reflected with the help of optics. This convex lens, the sensor characteristics are being detected in a sensory panel or an array board. Now stereo image. Talking about stereo image is a form of representation where the triangulation is being done. So stereo image represents the depth in a 2D image representation. The 3D, from the stereo image we can get the depth interpretation, depth value or interpretation or information we can get with the help of 2D image array. So 2D image array we can get the depth information by a stereo image. So this is basically the how it is being done with the help of stereo image. So elementary stereo geometry in a rectified configuration, if we see, so there is a point P, X, Y, Z transpose. We are having two observers C and C dash here. So they are both perceiving this point, and the difference is being calculated with the help of this distance H and baseline P. So how it is being calculated? So disparity. So disparity is what is disparity in the elemental stereo geometry rectified configuration? Disparity is the horizontal distance between the points C and U dash. This is a point U and this is the point U dash. So this disparity, this is U and this is U dash, and the distance between them, that is D, is equal to U minus U dash. Now from the similar right angle triangles UCB and CPA, what is UCB similar triangle? Similar triangle UCB is this triangle UCB. this triangle, and CPA. What is CPA? CPA is my this triangle, CPA. So what is being this done here? With the help of the similar triangles, U by F. So this U divided by this F. This distance divided by this distance, F distance, gives minus H plus X divided by Z. So H is here, our baseline, mid of the baseline distance, H, and X. X is my this distance. This shift from the center. So from this line to this line, this shift from the center, H by X, H plus X. So this distance, H plus X divided by Z. Where is my Z? My Z is this direction. So Z value, if we see here, so Z value is like this. So this is the Z value. So when H plus X, so this H plus X divided by Z value comes, we can say that we are having our triangulation process completed. So if we see here, this is my U, this is my U, this is my F. Okay, so this U divided by F is equal to minus of H plus X divided by Z. So this is my Z. H plus X is this distance. So if I do this, H plus X is this distance divided by Z. Z is how much? Z is like this. This value distance. So this distance is my what? Z value. So like this, we can do the triangulation process and get the coordinates like Z is equal to 2HF divided by U minus U dash, BF divided by D. The remaining coordinates of the considered three-dimensional point can be obtained is equal to the, X is equal to minus B U by U plus U dash divided by 2D. Then Y is equal to U equal to BV by D. So triangulation is a process of obtaining three-dimensional scene from its projected points in the two image planes. Now if we move to the image resolution technique, description of the details of an image holds higher resolution, more image details, resolution units, lines per meter, lines per inch, etc. So if we talk about the so this is my disparity. So this minus this is equal to D. Now U by F. U by F. What is U by F? U by F is equal to minus H plus X divided by Z. Now if you see this by the fundamental of your similarity of triangles, these two triangles, that is this triangle, my UCB, and this bigger triangle, my this triangle. So this triangle ECA CPA. From this U by F is equal to minus of H plus X divided by Z. So what is U by F? This distance divided by this focal length is equal to minus of H plus X. My since it is in the negative direction, if you see this is the negative and the positive direction from the center axis, then this is my H and plus X. X is my central shift divided by Z. So Z is my this axis length. Like now, since triangulation process is obtaining three-dimensional scene point from its projected in the two images plane. Now, if we talk about image resolution, descriptor of the details that an image holds, high resolution means more image details. So resolution units basically comes to lines per millimeter or lines per inch. Now, line pairs often used instead of lines. If we talk about a resolution of 10 lines per millimeter, what does it mean? It means that 5 dark lines alternating with 5 light lines, like 5 lines per millimeter. Now, while we talk about image resolutions, often expressed as 8 pixels to 64 pixels. So, they are often expressed as pixels to 64 pixels, and is not an authentic measure of an indicator of camera's ability. So often expressed as pixel count, it's not an authentic measure of an indicator of a camera's ability. Now if we go to pixel count, m cross n, megapixel count is pixel count divided by 1 million. So if we increase the pixel count like this, so the clarity of the image increases. Now, spatial while in machine vision systems which robots use for optical sensing of food particles, like spatial and intensity resolutions are two important parameters. Clarity of an image decided by a spatial resolution is not by total number of pixels. So spatial resolution is measured the smallest discernible detail of an image, like units, lines, pairs per unit distance, pixels per, it is represented by pixels per unit distance or dots per unit distance. So width of line is W, width of line pair is 2W, line pair per unit distance is 1/2W. Typical resolutions newspapers like 70 dpi, 75 dpi, images in magazines like 100 resolutions are like 100 dots per inch. What are dpi? Dpi are dots per inch. How many dots are present? Alternating dots are present per inch. So like this, the smallest discernible change in intensity level is captured. So influenced by noise, saturation and capability of human perception, we can get an idea of what is being done. So like this, intensity resolution, too much reduction in intensity causes false contouring. False contouring is an appearance of fine ridge-like structures in areas of constant or nearly constant intensity. So this is a 5 lines per pair per millimeter, 5 lines pair per unit distance. Now phase alternating line. If we come to phase alternating line, it's a color encoding system for analog television. It was one of the 3 major analog color television standards, the others being NTSC and CCAM. So NTSC is there, CCAM is there. Machine vision has been widely used in all aspects of food processing. At the same time, image processing is an important component of machine vision. Image processing can take advantage of machine learning and deep learning models to effectively identify type and quality of food. Subsequently, follow-up designs in the machine vision systems can address tasks such as food grading, detect locating of defective spots or foreign objects, and removing impurities. Now, machine vision systems characterizes of object image acquisition, image processing, image interpretation and output. So there is an object, image acquisition is there, image processing is being done, image interpretation is done, then further output is being generated. Now if we see a sample, suppose a food sample is there, some sample is there, image is being continuously acquired by the camera, and there is an illumination source, and then there is a computer which does the image processing and interpretation. So image acquisition plays a greater role. A machine vision system usually includes digital cameras and processing software running on computers and mechanical systems. The illumination device provides sufficient light to the object so that the camera can capture the high quality images of the object. The software, the computer can be process the images for different purposes. The processed image results are used by mechanical systems to make next operational decision. And MPS includes 2 main parts to enable objective and non-destructive food evaluation: acquiring and processing. Acquiring and processing. These 2 are important parts. Now if we see the stereo systems. Stereo systems refer to a set of cameras that can measure the depth from an object to the camera. Now compared with the traditional 2-dimensional 2D camera, the stereo images increases the depth of the one dimension with the goal of improving its representation in the real world. So if we talk about this point, the length, width and thickness of information were processed to calculate the volume and the mass of the potatoes, based on which the grading task according to mass was achieved. And subsequently the 2D and 3D surface data were integrated to detect the irregular shaped hump and hollow defects of potatoes using machine vision systems. What is a digital image? So 2D array of numbers are there representing a sample version of an image. The image defined over a grid, each grid location being called a pixel, represented by a finite grid, and each intensity chart is represented by a finite number of bits. A binary image is represented by 1 bit, gray level image is represented by 8 bits. Pixel and intensities. So a binary image is represented by 1 bit and a gray level image is represented by 8 bits. So while we talk about 2D array of numbers represented by sample version of an image, it is being defined over a grid, each grid location being called a pixel. So these are each pixel grid location, so represented by finite bit part, each intensity finite number of bits. Each grid. So each grid is basically called a pixel. So represented by finite reach, each intensity data is represented by a finite number of bits. So related to this grid, there are certain intensity data. these are actually each grid location is being called a pixel represented by a finite grid. Each intensity data is represented by a finite number of bits. A binary image is one which is represented by 1 bit. Gray level is represented by 8 bits. So if we talk about the glided distance, L1 city block distance and Chebyshev chessboard distance, so between A and B, so distance can be calculated with the help of different formulas. So Chebyshev chessboard distance is basically it is the distance between maximum of xa minus xb, which is being modulus, and modulus by a minus by b, the maximum value of which it is gives that Chebyshev distance. Now normal distance calculation, we know that the distance between a and b is represented by xa minus xb square y plus ya minus yb square. This distance can be any distance like this. Like this distance, like 1.41 between the center point 1. So from the center point, this distance is 1.41. This is 1. Again, these are 1. The diagonal distance is a 1.41. In L1 city block, the diagonal distance has become just the double of the adjacent block distances. In Chebyshev chessboard distance, that is consider all distance, even the diagonal one are also the same, because it takes the maximum modulus value of the between 2 points. Maximum modulus value between the 2 points. So this is the basically technique which is being used. Now if we talk about the number of bits required to store an image, this is basically an important parameter, like some so it is represented by m cross n cross k. So m cross n is my spatial resolution of an image, and the number of pixels or the intensities, the resolutions. So if there are, so L is equal to 2 to the power k, so the number of bits required to store an image is k 2 to the power k times the so m cross n cross k times the distance. So basically k is the number of bits. So if I say that the resolution of an image, so resolution of an image, we know that it is spatial, might be spatial resolution, or it might be intensity resolution. What is spatial resolution? Number of pairs of line per unit distance. What is an intensity resolution? Smallest discernible changes in the intensity of level. So if there is an 8-bit image, so the number of spatial levels or spatial resolution levels can be given by 2 to the power 8 which is equal to 256. Now if we talk about spatial resolution, now if we talk about the neighborhood of a pixel, so let me go to the thermal imaging tools. The thermal imaging tool is the part of the electromagnetic radiation within the range of 0.78 to 1000 millimeter. In thermal imaging system, the radiation pattern of an object is transformed into visible images. The temperature and emissivity of objects affected the level of released radiation. So these imaging systems consist of an camera, optical system, lenses and filters, array signals, image processing systems, etc. An example of measurement setup is the shown in the figure. So this is a thermal imaging system. So they employ advanced vision tools. They are visualizing the food. These are having this thermal imaging systems. Now typical solutions are like camera is there, various camera, thermal cameras are there, like FLIR, A400 FLIR, AXP FLIR, AXS, A315, A615. Typical applications are packaging inspections, etc. Now monitoring templates. In the food industry, it is essential to carefully control the temperature to the shape of perishable goods throughout the manufacturing process, from production to transportation and storage, always to sales. So image interpretation is there. Let me see how much is there. So if I see this image interpretation, it composed of elements. It is composed of elements which are basically basic elements: tone, color, high order spatial arrangements. Arrangements can be of size and shape, geometric arrangement of tone and color, texture, pattern, spatial arrangement of tone and color, height, interpretation based on lower order elements, sites, location elements, technique and aids, training sites, collateral material. So they detected pitch of a fruit which is using a rotating hyperspectral imaging test bed. So data processing analysis, the image process or analysis is performed using the environment visualizing software The specific wavelengths could recognize complex images and proceeded as the following. Firstly, the average spectra of different regions of decayed pitches treatment groups were manually extracted. Secondly, the spectra that represents the optimum wavelengths of the rottenness and the second sound areas were selected. Thirdly, the optimal wavelengths were applied to increase the contrast between the rotten and sound tissues. Fourthly, segment and decayed areas of the image. Finally, the raw material of each decayed pitch were extracted from the decayed areas by using the algorithm of the MATLAB. In this study, autoscale was used as the pre-processing by using PLS Toolbox 7.5 eigenvector research included and was used by Wash USA. Now these are various work done the conceptual view of an hyperspectral image. What we see here, this is a radiative reflectance and this is a wavelength. So radiative reflectance and wavelength, the values are being plotted for different values of we can get the various graphs for different wavelengths. At different wavelengths we can get if it is rotten, if it is sound, edge or background. So with these values, RGB image extraction, we can calculate the histogram and thresholding. A flow chart, this is a flow chart image processing algorithm of decay detection. So how the decay is being detected. So this is a relative reflectance value and the wavelength value. How much of the light is getting reflected from this reflectance value we are perceiving with the hyperspectral camera. Now feeding operation type, food operation type, there is a material handling, there is an assembly part and there is a finishing process. So material handling deals with primary packaging, pick and place, sorting, grading. Assembly deals with forming, decorating, forming. Secondary finishing process deals with secondary packaging, tertiary packaging, palletizing. If we do a study, if this is a food, if I say this is a food sorting operation, robotic food sorting operation, robotic food sorting operation algorithm, what we see here, that there is a start. Is this foodstuff raw? If it is yes, then is it whole? If it is again yes, is it rigid or non-deformable? These are food characterizations is being happening. If we see the F vision, the other vision, if this food stuff is raw, if it is yes, is it whole? The answer is no, is it segmented? If it is yes, then it is characterized as non-rigid, non-deformable. Now again the algorithm states that if it is no, is the food stuff cooked? If it is yes, is it whole? Then it is semi-rigid, deformable. Otherwise it is segmented and semi-rigid, non-deformable. In this way basically the algorithm goes and the machine processes the data. Is the food stuff cooked? Is it frozen? If it is yes, is it whole? Either yes, is it rigid and non-deformable? Is it segmented? Then it is rigid and deformable. Now we come to an important criteria which is being used, which is actually the selection of industrial robots for food manufacturing applications. So our new automatic dispenser solution like make Flippy 2 even more independent. We choose from single or dual hopper dispensers with frozen or refrigerated storage. So Flippy 2 features up to 3 auto bins and uses AI vision techniques, artificial intelligence vision techniques to automatically recognize and transfer food. Team members simply place food in an auto bin and Flippy 2 will fry it into perfection every time. Now selection criteria is there. There is a payload, number of axes is there, work, area, accuracy, precision, joint limits of position, velocity and accelerations are there. So main selection criteria for robots are: there is a payload, is the weight of the robot that can lift. Payload includes the weight of an end of an arm, tool, UAT and the weight of a product being picked. Now number of axes, most industrial robots utilize 6 axes which give them the ability to perform wide variety of industrial tasks compared to robots with fewer axes. 6 axes allowed robot to move within the X, Y and Z planes as well as position itself using roll, pitch and yaw movements. This functionality is suitable for complex movement that simulate human arms such as reaching for grabbing and placing down a part. So Workspace. Workspace, a robotic workspace is a space in which the robot operates on the production line or in a work cell. Each industrial articulated robot has a very specific workspace for which it can operate and move around within. It is very important to discuss our specific needs to find out the best automated fit for our production line. So, if we talk about workspace, a Cartesian robot gives a workspace of which type? Yes, it is cuboid. A cylindrical robot gives a workspace of cylinder or a concentric cylinder, if you can say. And then a spherical robot gives a workspace of a sphere. Scalar robot gives the donut shape, articulated arm with the work shape of a donut or bean shape. Similarly for a scalar robot. So, like this. So scalar robot, let me check. This is basically the half cylinder type of a workspace. This is the ability of the robot to reach a specific program position within a minimum of error. So measurement method is built around the Mahar OMS coordinates measurement machine system. So technical specification of the machine is like granite prototype 4 body 8 turns with moving table y-axis. Measurement is built around Mars OMS 100,000 coordinate measurement machine. A typical specification of the machine is measuring volume is 1000 into 1000 to 600 mm cube. A volumetric accuracy has been given. U3 is plus minus 2.2 plus L by 300 micrometer as L measuring distance in millimeter. Sensors, there are 2 CCD cameras, reference camera and other with 0.5x smaller magnification, and 2 lenses 3x and 10x corresponding to the field of view, 4 plus 3 mm and 1.2 to 0.9 mm. All axes have air bearings and ball screwdrivers. Direct position measurement is made using glass beer bar linear encoder. Calibration of the machine is maintained regularly according to traceability requirements. Figures 3 and 4 present the CMM machine and measuring setup. Precision, also referred to as repeatability in robotics, is the ability of an industrial robot to bring its end effector to the same position and orientation over and over again. Accuracy of the robot is analyzed according to ISO 9283 standard. Positional error is determined by each point in the calculating the distance between the measured and the reference points. So repeatability and accuracy basically different. So precision is the ability of industrial robot to bring its end effector to the same position orientation over and over again. Accuracy of the robot, whereas, is analyzed according to the positional error from each point calculating distance between the measured and the reference value. So this is basically bad repeatability but good accuracy. So it's a good repeatability but bad accuracy. So accuracy is how much the end effector or the output is close to the original value. So this is for case 1 is the example of bad repeatability and bad accuracy. Repeatability is bad because the end effector or the values are not close to each other. There is a great gap between them. So good bad repeatability and good accuracy is that the majority of the values are within our destined target, but repeatability is varying. Repeatability is varying greatly with a huge distance between them. So this is an example of good repeatability. The value data points are close to each other, but a bad accuracy. Now, if we talk about the if we talk about again the values of this detail, we see that this is a case 4 is an example of good repeatability and good accuracy. All the values are close to the target, all the repeatable points are close to the target. Now we study the joint limits.